For as long as humanity has looked up at the night sky, Mars has been a symbol of both mystery and intrigue. The red glow of this distant world has sparked the imagination of astronomers, poets, and dreamers alike. It beckons with questions. What lies on its surface? Could it have once supported life? And if so, what happened to that life? In ancient times, Mars was the stuff of myth, referred to as the god of war, in Roman lore, a symbol of power and destruction. Yet, as our understanding of the cosmos expanded, so too did our curiosity about this cold, enigmatic world. The 20th century saw the first modern attempts to answer these questions, as the advent of space exploration allowed us to reach beyond Earth's atmosphere and study other planets. Mars became the focus of our attention, not as a mere point of light in the sky, but as a real-world destination waiting for discovery. But Mars, unlike the worlds of science fiction, revealed itself to be much more mysterious than we ever expected. Was it once a thriving world, teeming with life, or had it always been a desolate wasteland? The answer to this mystery lay not in our telescopes, but in the robotic explorers we sent to the planet's surface. These rovers would become our eyes and ears, sending back evidence from the Martian soil that would forever change our understanding of the planet and of ourselves. In the early days of space exploration, missions to Mars were fraught with challenges. The Mariner program in the 1960s offered humanity its first glimpses of Mars, pictures from spacecraft that passed by, showing a planet pocked with craters, dusty deserts, and a thin, unwelcoming atmosphere. But there were clues, faint hints that Mars might have been different long ago, a world with conditions suitable for life. It wasn't until 1976 that humanity's ambition truly reached the Martian surface. The Viking landers, NASA's first successful mission to land on Mars, made history, performing groundbreaking experiments to search for life and analyze the planet's surface. While the landers didn't find signs of life, they gathered vital data that opened new avenues of inquiry. The Viking landers did not find the lush, green landscapes we had dreamed of, but they did uncover something else, a world shaped by forces we were just beginning to understand. Mars was an ancient planet with a rich geological history, its surface carved by volcanic activity, massive dust storms, and the faint remnants of an atmosphere that once may have been thicker and warmer. It was clear that Mars had once had the potential to support life, but the search for concrete evidence had only just begun. In 2004, two robotic explorers, Spirit and Opportunity, would redefine how we studied Mars. These weren't simple landers. They were rovers, mobile robots designed to traverse the surface of Mars and seek out the clues that could tell us if life had ever existed there. Spirit landed in the Gusev crater, an area believed to have once been a lake, while Opportunity touched down on the opposite side of the planet, in Meridiani Planum, a flat plain that would soon reveal secrets beyond our wildest expectations. For years, Spirit and Opportunity traveled over Martian terrain, sending back images and data that told a story of a planet in transition, once warm, wet, and potentially habitable, now a frozen world with a thin, dry atmosphere. Spirit's mission was to study the geology of the planet, but what it found was extraordinary. At first, scientists expected to find only the typical signs of a barren landscape. Instead, Spirit uncovered features that suggested Mars had once been volcanically active, with ancient lava flows shaping the land. And then, there was the discovery of rocks and minerals, many of which had been altered by the action of water. Spirit revealed something crucial. Mars had once had the ingredients necessary for life. But Spirit wasn't just digging into the Martian surface. It was digging into our assumptions. The planet that had once seemed so inhospitable was now showing signs of past water flows, as if it had once been a warmer, wetter world, a world that may have supported life. The evidence was clear. Mars had a history that was much more complex than we ever realized. On the other side of Mars, opportunity was rewriting the history of the planet's geology. The discovery of hematite, a mineral that forms in liquid water, was a game changer. The deposit's opportunity found suggested that Mars had, at one time, had vast amounts of water, enough to carve out riverbeds and form shallow lakes. Opportunity's findings suggested that liquid water had once flowed across the Martian surface for extended periods, enough time for life to have potentially taken hold. Opportunity's mission lasted far beyond expectations. What was meant to be a 90-day exploration turned into nearly 15 years of groundbreaking discoveries. And with each new finding, Opportunity proved to the world that Mars was far more dynamic than we had ever thought, and far more Earth-like than we could have imagined. For more than a decade, Spirit and Opportunity uncovered evidence that Mars had once been a warm and wet world. These discoveries forced scientists to reconsider everything they thought they knew about the planet. No longer was Mars merely a cold, barren desert. It was a planet that had undergone dramatic changes, with the potential to support life in its distant past. But these rovers were just the beginning. With their success, the question shifted: could life have ever existed on Mars? What other secrets were still hidden beneath the planet's surface? Enter Curiosity, a rover designed to explore not just the surface of Mars, but the deeper question of its habitability. Launched in 2011, Curiosity touched down in Gale Crater in 2012, armed with the most advanced scientific instruments ever sent to Mars. Its mission was clear: to explore the ancient Martian environment and determine whether Mars had ever been capable of supporting microbial life. Curiosity's landing was one of the most ambitious events in space exploration, and it did not disappoint. As it roamed Gale Crater, Curiosity revealed complex layers of Martian rock, some of which had been altered by water long ago. These rocks contained the signature of ancient lakes and rivers, proof that Mars had once harbored the key ingredients for life. Curiosity went further, drilling into the Martian surface to extract samples for analysis. It found traces of organic molecules, complex carbon-based compounds that are the building blocks of life. These compounds were found in rock samples that had been buried deep in the Martian soil, preserved for billions of years. It was the strongest evidence, yet that Mars may have once had the right conditions to support microbial life. Curiosity's discoveries didn't just confirm what Spirit and Opportunity had suggested. They provided a direct connection between the history of Mars and the possibility that life might have once existed there. In 2021, Perseverance touched down in Jezero Crater, an ancient river delta where Mars' past may have been preserved in the rocks. Perseverance's mission was to search for definitive signs of past life, collect samples for future return missions, and push the boundaries of exploration with cutting-edge technology, including the first-ever helicopter to fly on another planet, Ingenuity. Ingenuity's flight was a historical moment, a demonstration of technology that could one day be used to explore Mars from the air, scouting locations that rovers can't reach. Perseverance continues its mission, taking samples of rocks and soil that will one day be returned to Earth, where scientists will analyze them with the tools and technology that Mars itself cannot provide. The search for life continues, but Perseverance's work is already laying the foundation for the next phase of Mars exploration. As we look ahead to future missions, including the possibility of human exploration, we are closer than ever to unlocking the mysteries of Mars. Through the eyes of the rovers, we've come to understand that Mars is far more than just a lifeless world. It is a planet with a rich, complex history, one that holds clues about the evolution of planetary environments and the potential for life beyond Earth.